a remarkable object has recently streaked toward Venus at a speed of nearly 140,000 miles per hour, emitting an unsettling glow. When astronomers first spotted this 20-kilometer visitor from another star system, they expected to see the familiar dance of ice turning to vapor under our sun's heat. Instead, they found something that has the entire scientific community divided right down the middle. Is this the first confirmed alien technology to visit our solar system, or are we witnessing the most bizarre natural phenomenon astronomy has ever recorded? Right now, as I speak, this mysterious object designated 3I Atlas is racing toward Jupiter, and we have maybe 6 months before it vanishes into the cosmic void forever. The clock isn't just ticking on solving this mystery. It's practically screaming. And here's what makes this discovery so incredible. Harvard's Avi Loeb, the same scientist who sparked global debate by suggesting our first interstellar visitor, Oumuamua, might be alien technology, has just published a paper claiming this new visitor shows signs of nuclear propulsion. Let me illustrate the scenario that is keeping astronomers worldwide awake at night. On July 1st of this year, NASA's Atlas telescope detected what initially appeared to be another space rock. Within hours, orbital calculations confirmed something extraordinary. This wasn't some asteroid that had wandered too far from the belt. This was an interstellar traveler, only the third confirmed visitor from beyond our solar system. But here's where things get weird. Really weird. If you've ever seen a comet, you know they follow predictable rules. They develop tails pointing away from the sun. They brighten on the side facing our star. They show spectral signatures of water vapor and carbon compounds. 3I Atlas breaks every single one of these rules. The object's brightest region sits on its leading edge, the side plowing directly into the solar wind. That's like watching a car's headlights get brighter when it drives into a sandstorm. The spectrum shows none of the expected comet signatures. No water lines, no carbon monoxide, no organic compounds. Just smooth, continuous light across infrared and visible wavelengths. Even more puzzling is the efficiency. Whatever process is creating this light converts energy with nearly 80% efficiency. The best laboratory experiments with exotic reflective coatings have achieved maybe 25%. We're looking at something that shouldn't exist according to our current understanding of natural materials. Loeb and his colleague Carson Ezell have built their case on 5 key observations that individually might be explained away, but together paint a picture that has even skeptics taking notice. First, the orbital geometry. 98% of known interstellar objects arrive tilted at steep angles to our solar system's plane. 3I Atlas lies almost perfectly flat, a coincidence with odds of roughly 1 in 500. Second, those close planetary encounters I mentioned earlier. Computer simulations show this object skimmed past Venus, Mars, and Jupiter at distances that provided maximum gravitational assistance. The probability of randomly hitting all 3 optimal zones, about 0.5%. Third, timing. The object's closest approach to our Sun occurred while Earth was positioned on the opposite side of our orbit. If you wanted to study our solar system while avoiding detection by our most powerful radio telescopes, you couldn't plan it better. Fourth, that forward glow I described. Loeb's calculations suggest a compact nuclear reactor driving an electromagnetic engine could produce exactly the infrared signature we're observing. Finally, there's the size paradox. Natural objects larger than 10 kilometers should be incredibly rare among interstellar wanderers. the physics of planetary formation and ejection just doesn't favor creating massive nomads. That is, of course, unless they were purposefully constructed to be that large. Now, before you start planning your welcome party for our alien visitors, let's hear from the other side. Oxford's Chris Lintott called the artificial interpretation complete nonsense during a live BBC interview. His argument centers on selection bias. Once you know an object's unusual orbit, he argues, you can make any trajectory seem improbably perfect. The European Southern Observatory's Marco Micheli points to spectral data showing faint traces of cyanogen and diatomic carbon, classic comet fingerprints that emerge as the object heats up near the Sun. The Zwicky Transient Facility has noticed that the brightness changes in a regular pattern every 7.5 hours, which matches what we expect from a comet that has an elongated spinning core. Their conclusion? Just another dirty snowball from space, albeit an impressively large one. This debate isn't happening in isolation. Over the past 8 years, we've encountered 3 interstellar visitors, each more puzzling than the last. First came Oumuamua in 2017, accelerating away from the Sun with no visible jets or outgassing. Then Borisov in 2019, acting like a textbook comet, complete with tail and familiar spectral lines. Now, 3I Atlas appears to be intentionally perplexing everyone involved. Loeb sees a pattern suggesting we're witnessing different types of artificial probes. Critics argue we're simply getting better at detecting these rare natural objects and falling victim to our confirmation bias. The truth likely lies somewhere between these extreme positions. But here's what makes this moment unprecedented in the history of astronomy. We now possess the tools necessary to conclusively resolve this debate. 3 critical tests are already underway, and their results will arrive before the end of this year. The first test is infrared spectroscopy. A natural comet should show brightness spikes at specific wavelengths where organic compounds absorb and re-emit sunlight. A nuclear reactor would create entirely different spectral fingerprints, particularly around the wavelengths where hot uranium compounds glow. Secondly, we should consider the measurements of acceleration. If this object speeds up or slows down by even centimeters per second beyond what gravitational forces predict, we're looking at active propulsion. Modern tracking systems can detect changes smaller than a gentle breeze on Earth. Third, we can use radar echoing. NASA's Deep Space Network can bounce radio signals off the object's surface within the next month. A solid metallic structure returns a sharp, clean echo. A porous, icy nucleus scatters the signal, creating a fuzzy reflection lasting several milliseconds. The James Webb Space Telescope is already booked for 12 hours of observation time in mid-August, hunting for heat signatures that could distinguish between natural sublimation and artificial energy sources. The brand new Vera Rubin Observatory will track rotation patterns and surface composition changes as the object continues its journey outward. Every day that passes, 3I Atlas pulls farther from the Sun, growing cooler and dimmer. By January 2026, it will have moved beyond Jupiter's orbit, become fainter than Pluto, and be essentially invisible to Earth-based telescopes. After that point, no human instrument will ever detect it again. The window for answers is closing faster than any astronomical mystery we've ever pursued. Even Loeb's most scathing critics privately express their hope that he is correct. A confirmed alien spacecraft would revolutionize our understanding of the universe overnight. But a confirmed natural comet would also fill crucial gaps in our knowledge of how planetary systems eject material into interstellar space. The universe has no obligation to make things easy for us. Occasionally, the most extraordinary explanations turn out to be correct. Sometimes the most mundane interpretations hide profound truths. What makes this moment so electric is that we don't have to wait decades or centuries for an answer. The next 100 nights of observation will determine which future we wake up to. Will tomorrow's headlines read, "NASA confirms alien technology," or will astronomers quietly add another entry to their catalogue of interstellar comets? Either outcome rewrites textbooks and reshapes our cosmic perspective. As 3i Atlas continues its lonely journey toward the outer solar system, carrying secrets we may never fully unlock, one thing remains certain. We are living through a pivotal moment in human history when our technology has finally advanced enough to study visitors from other stars in real time. The data is coming in. The measurements are being made. And very soon, we'll know whether we've just witnessed our first glimpse of alien engineering or discovered the most unusual natural object ever detected. Keep watching the skies, keep questioning everything, and stay tuned. The universe is about to give us an answer that will change everything.